Algebra 2, Lesson 84, Solutions of Equations. So, we're going to be talking about some geometric truths about equations. So we've been solving linear equations, and I've already told you guys that the solution of these equations is where the two lines meet, right? Now, this is only partly true. There's actually three possibilities when we're graphing two lines. The first possibility is that the two lines are different and they meet in one point. So that's what we've been dealing with so far. These are called consistent equations. Consistent equations are equations of lines that touch at only one point. Now, the other option is this one, which is what we call dependent equations. What this actually is the two equations you are solving are both equations of the same line. See here, the equations they give here, they have y equals x minus 2, then we have 2y equals 2x minus 4. This is the same equation, but just multiplied by 2. So the other option is that perhaps the two equations that you're dealing with are just two different versions of writing the same equation, right? So they're essentially the same line. Now the third option, which is one we have not dealt with yet, these are called inconsistent equations. And what happens here is the two lines never touch because they're parallel. So option 1, they touch at one point. Option 2, they are the same line. Or option 3, they never touch. So touching, consistent. Same line, dependent. Never touch, inconsistent. Now, and there's a telltale way to find out about these equations simply by solving them. So, hold on, I gotta erase this example. This one is no good. We'll talk about inconsistent and dependent equations really quick as soon as I get these examples down. And the reason why is because we already know how to solve consistent equations. We use substitution or elimination, and then we get a good answer, and we know what x and y are at the point where they meet. Now, in order to figure out if an equation is consistent or inconsistent, we're going to have to look for something else when we try to solve. Okay, and both the consistent and inconsistent equations will have something in common. When we substitute or eliminate to attempt to solve them, all of the x's and all of the y's will go away. All right, so that's one key thing to spot for consistent and inconsistent equations, is when we try to solve them, all of our x's and all of our y's disappear. So let's go ahead and try to solve this one. Let's see here. I can solve this top equation for y really easily. I'll just add 2x to each side. So that cancels. So then I get y is equal to 2 plus 2x. I can substitute that in here. So if I substitute that, we get 2x is equal to 2 plus 2x, and then plus 2. Right. Okay. So from here, I'll go ahead and I'll subtract 2x from each side, minus 2x. That's going to cancel. That's going to cancel. These combine, and then we get 4 on this side. And then on the left side, we see both the x's canceled, right? So this is a little confusing, right? I mean, there's nothing over here. So 2x minus 2x is equal to 0. Okay, and then over here on this side, we have 4. All right, so this is the trademark of consistent and inconsistent equations. Or I'm sorry, not consistent, dependent and inconsistent equations, is all the variables will be gone. Now, the thing we notice about this equation is we get 0 equals 4. Is this true? No, it's not. 0 is absolutely not equal to 4. So, whenever you try to solve an equation and all of your variables disappear, and the answer you get is not true, then we find out that these equations are inconsistent. This means that these lines never touch, and they're actually parallel to each other. And to show you the graph of these two lines, that's actually right here. This is the graph of those two lines if you solve them for y and write them in y equals mx plus b form. They're parallel lines, they never touch, which is why when we try to solve the equation, we get a statement that is not true. Now, what happens if we try to solve two equations of the same line? And this is another reason why and so this is why when you guys were learning how to substitute and eliminate, I kept telling you cannot substitute one equation back into itself because you'll end up with 0 equals 0. because you're essentially taking one line and putting it back into itself. And so that's what an inconsistent equation is. So if we do an inconsistent equation, or not an inconsistent, a dependent equation, we'll get something like this. We could have that y minus x equals -2, and then we can also have that 2y equals 2x minus 4, right? So we've got two equations. Let's try to solve them. Let's see here. Yeah, I'll try to solve, I'll solve this one for y. So if I add x to each side, this one becomes y equals -2 plus x. If I plug that in for this right here, I get 2 times -2 plus, oops, not -2x. Ooh, let's rewrite this. Sorry. So if I substitute this in here, I would rewrite that equation as 2 times -2 plus x, worst plus sign ever, and that would equal 2x minus 4. Now, when I distribute here, I get -4 plus 2x equals 2x minus 4. If I subtract 2x from each side, the x's cancel. And then I'm left with -4 is equal to -4. So this is what we call a dependent equation, right? So this is dependent. And so the key thing here is for inconsistent equations, when you try to solve them, all the variables will go away and you're left with a statement that's false. That's how you know it's inconsistent. If it's dependent, you will try to solve the problem, all the variables will go away and you're left with a statement that's true. And then understand, inconsistent means these lines are parallel, dependent means that these are the same line. All right. And I believe that's it for this lesson. Yep, that's all there is for this lesson. If you guys have any questions, let me know on Moodle, and I will see you in class.